Okay, welcome back. In this video, I'm going to cover the 12 different paths that are used in solving linear functions. This is a kind of video that you might want to watch a couple of times if you don't get it the first time, because I'm going to go rapid fire through these 12 different paths, and if you don't catch something, you might want to pause it, go back a little bit, and watch it again. So let's just run through here and just keep that in mind. Okay, so we have verbal and graphic are going to be the first two things we look at. So going from a verbal description to a graphic representation of a function looks like this. Line going through the origin with a slope of 5/3. So that means the line, so I'm drawing, the graphic is going to be in the plane. So I draw a line and it's going through the origin, so that's 1 point on the line. And it has a slope of 5/3, so that means for every 1, it goes up 5/3, which is a little more than 1, isn't it? Or if I use proportional reasoning, that means it goes up 5 for every 3. So 1, 2, 3, 4, 5 over 1, 2, 3. So that would be another point on the line. And it looks like that. Okay, next, take a graph and go to a verbal description. So what we have here is 2 points. It's going through 0, 6 and 12, 0. So that means it has a slope going down 6 over 12. So down 6 over 12. And that would be negative 6 over 12. Or if you want to divide the top and bottom by 6, we could simplify it to be negative 1/2. Okay, so a verbal description might be the line starts at 6 and goes down 1/2 each time. Right, so that would give you a verbal description. So each time it's going down 1/2 for every 1. Right. Okay, so that's the verbal description of the graph. Oh, you guys couldn't see that. Let's put it up here. The line starts at 6 and goes down 1/2 each time. Alright, so next we're going between numeric and graphic. So we're given a numeric representation of the function and we want to switch to a graphic. So in this case we start at negative 2, 2, and the next point is at 5, 1, 2, 3, 4, 5, negative 3. Okay, so we have a line that looks like that. So that might be enough of a graph, but a lot of times we want to find out where is the y-intercept, so let's go ahead and figure that out. It's going down, let's see, 2 and then 3 more, so it's going down 5 and over, so negative 5 over 2 and 5 makes 7, so it has a slope of negative 5/7, so usually the slope is important. So for every 1 it's going down 5/7. So if it goes down 5/7 twice from 2, so it's going 2 down 5/7 down 5/7. 2 is equivalent to 14/7 as a fraction, and I'm going to subtract 2 5s is 10, so I'm going to subtract 10/7, and so I get 4/7. So, oops, 4/7. So this y-intercept then would be 0, 4/7. So you could say that it's intersecting the y-axis at 4/7 and going down 5/7 each time. Okay, taking a graph and turning it into numeric. So here's a slope of 1 to 1 starting at 2. So maybe a numeric representation would be 0, 2, and then it adds 1 to the x and adds 1 to the y each time. So this one's fairly easy. Just adding 1 to each time, right? That's enough for that one. Okay, next we have our symbolic to numeric. So if we start with the function as a symbol, we can convert it to a numeric just by plugging in some values, and it's really your choice. I usually like to start with 0 and go 1, 2. So let's start with negative 3 times 0 minus 2. So that's 0 minus 2 is just minus 2. So here's the values. And negative 3 times 1 minus 2. So that would be negative 3 minus 2 would be negative 5. And then negative 3 times 2 is negative 6. Minus 2 would be negative 8. And it should be that it's going down by 3 each time. Alright, now taking the numeric and we're going to go to a symbolic. So right here we're given 2 points, and it could be given to us like this or like this. So what's happening, it's this is not changing by 1 each time, so we don't have a unit change. So we need to maybe we can intermediately go to the graph. So what's happening here, it starts at 1 3, and it's going to 5 7, so 2 5 7, this is 5 7, and this is 1 3. So it goes from 1 to 5, so it's changing by 4 in the x direction, and it's going from up from 3 to 7, it's going up 4 in the y direction. So the slope is 4 to 4, or if I divide the top and bottom by 4, I get 1 over 1. So my slope is 1, and my y-intercept, then I could think about tracking it back to there, would be 2, right? But let me show you another method. So you have y equals mx plus b. So I figured out my slope just by comparing those 2 points, how they change in the y direction and the x direction. So, and then I can plug in one of those points. So how about I plug in the first point? When y is 3, x is 1, and my slope I figured was 1 plus b. So I could figure out that b, so 1 times 1 is 1, so b, so what number do I add to 1 to get 3? That's a 2, right? So b is 2. So my equation, or my function as a symbol, would be 1x plus 2, or y equals x plus 2. Okay. And you can check to make sure that when you put in a 5, you get 7, right? When you put in a 1, you get 3. Yeah, checks out. Alright. A line with unit rate of change decreasing by 2 initially starting at 10. So we want to go from the verbal description to the symbolic. So how about we say, well, make my function g of x is unit rate of change. It's decreasing by 2. That means negative 2 is my unit rate of change. X initially starting at 10, so plus 10. That's it. Given a symbolic, go to the verbal. So I have a line starting at a half. So starting at 1/2, the line decreases, it's going down, negative 4/3 by 4/3 each time. Okay, that'd be a verbal description. Alright, next we have verbal to numeric, numeric to verbal. So we start with a numeric description. Let's write a verbal description. So it looks like we have, it's going up by 2 each time, plus 2, plus 2. And so if I track back to 0, I would, from 1 to 0, I would subtract 2 to go backwards. So it'd be at 0, 3 would be my initial condition. So we'll say starting at 3, the line increases, right, it's going up each time now, by 2 each time. Okay. The line has an initial value of 100 and increases by a rate of 5. At a rate of 5. So what does that mean? I can change it to a numeric, right? X and Y. So if I start, so 0, initial condition, 0, 100, and increases by 5 each time. So the X value at 1 would be 105, X value at 2 would be 110, and I keep adding 5 each time. Okay. Last two. So now we're going between the graphic and the symbolic. So graphically, we have a line going through -2 and up to 5, 2. So symbolically, we'd have, I don't know, we'll say h of x is the slope of the line. What is the slope of the line? It's going up 2 and 2 more, so it's going up 4, and it's going over 5. So its slope is 4/5 x, and it's positive. It's going up and to the right. And my y-intercept is -2, so that's my initial condition. Alright, and last but not least, function f of x is -0.4x plus 13.2. So if I want to go to a graphic, my line is going to be going through this point at 13.2, and it's going to be going down 0.4 each time. So it's just, I'll just put some labels to those points. So what would that be? 13.2 minus 0.4 would be borrowing, get an 8, so 12.8. So this point right here would be 1 comma 12.8, and maybe if I made a table, I know this is supposed to just be the graph, but I sometimes can't help myself. I like to use the numeric as well. So 0, 13.2 was 1 point, and then it's 1, 12.8, and then it would go down again by 0.4 to 12.4. Okay, so there are the 12 steps going between each of those different types: verbal, symbolic, graphic, and numeric. Okay, we have some practice problems for you.